All right, guys, welcome to this page of the notes, and here's what the kinds of problems you can expect to see when it comes to dealing with all that conceptual information we just got about polynomials. What I will do is I will give you the graph of a polynomial, and then I will go ask you a number of questions based on that graph. So anyway, here's our graph, and we're going to go ahead and jump right into this. The first thing I ask you is the number of real zeros. Well, remember, the number of real zeros is the number of times the polynomial crosses the x-axis. In this case, I crossed the x-axis twice. I don't have any points of tangency, so I don't need to worry about multiplicity. I have 2 real zeros. The number of imaginary zeros. Well, I actually don't know that yet. Remember, imaginary zeros aren't going to show up as anything, so I'm going to probably have to come back to that part because there's nothing I can really do about it just looking at the graph. But then I come here and I see the number of turning points. Well, I can do that. Remember, turning points are everywhere you're going to change direction. 1, 2, 3. I changed direction 3 times, which means that I have 3 turning points. Then I ask you the degree of the polynomial. Well, I take a look at it. I see both ends are headed in the same direction, and both ends are headed in the negative infinity. Well, the only way that happens, both ends headed in the same direction, is if the polynomial is of an even degree. State the degree of the polynomial. I actually don't know that yet. We'll have to come back to it. Sign of the leading coefficient. Well, we already talked about this. Since both ends are headed in the same direction and both ends are headed to negative infinity, I know that my leading coefficient needs to be negative. All right, now we come to where we take a little bit of kind of a round the backside kind of approach to this. Really, really important here, number of turning points. Remember, I mentioned a page or two ago, we call the degree n, and the turning points is equal to n minus 1. Meaning, once you know the degree of the polynomial, the number of turning points will be 1 less than that. Well, I was able to look at my graph and see the number of turning points. I have 3. Well, since the number of turning points is 1 less than the degree, I actually do know what the degree of this polynomial is. If I have 3 turning points, the degree would be 1 more than that, which is 4. This turns out to be a 4th degree polynomial. Sorry, I don't want black, I want green. A 4th degree polynomial, which is totally in keeping with what I found right here, that it should be even. 4 is an even number, and that allows me to go back and figure out the last part of this. Since the degree of the polynomial represents also the number of zeros the polynomial should have, I not only know that I should have 3 turning points because the degree is 4, but I also know that I should 4 zeros, of which 2 of them are real. So how many have to be imaginary? You guessed it. There's got to be 2 imaginary zeros. The last thing I'm going to ask you to do is just give me a quick description of the end behavior. I want to know what happens to the function as x goes to negative infinity. As my domain heads out in this direction to negative infinity, what happens to my polynomial? Well, my polynomial is headed in the negative infinity direction, right? But end is headed down, so I'm going to put negative infinity. On the other side, as x heads to positive infinity, as my domain values head out there to positive infinity, what happens to my function? Well, it is also headed in the negative infinity direction, so we'll just go ahead and throw a negative infinity right there. I apologize if the yellow is a little hard to see, negative infinity and negative infinity. Guys, this takes care of this problem. I got a few more for you on the next couple of pages of the notes, so head on over and I'll meet you guys there.